Okay, picture this. You're about to spend, let's say, $1 billion on a single project. An AI project so massive, it's going to take a whole year to run. I mean, where do you even start planning something like that? Well, the answer isn't in some super complex code or a giant spreadsheet. It starts right here, on a napkin.
But seriously, how do you plan for something like that? You're talking about a project that's just burning through cash, tying up thousands of the world's most powerful computers for months. You can't just cross your fingers and hit the go button, right? One tiny miscalculation could literally mean millions of dollars down the drain.
And the answer? You'll love this. It's completely counterintuitive. You don't start by writing a single line of code. Nope. You start with probably the simplest tool you can imagine, a napkin. And this brings us to the hero of our story, napkin math. It's basically a set of surprisingly simple back-of-the-envelope calculations that act as the blueprint for these monster AI models. This isn't just doodling, it's the absolutely essential first step that figures out the time, the cost, and all the resources for the entire project. And this whole enormous, complicated problem, it really just boils down to two fundamental questions. That's it. First, how much work actually needs to get done? We call that compute. Just think of it as the total number of calculations. And second, how much space do I need to do all that work? That's memory, the actual physical room on the chip to hold all the numbers. So let's tackle that first question, right? Counting the compute. You might think the math behind AI training time is going to be insanely complex, but honestly, it's surprisingly elegant. It all revolves around a single number, just one, and that number is 6. Just kind of burn that into your brain for a second, because we're about to find out exactly where it comes from. Okay, here it is, the secret sauce. The total compute you need, that's the total number of calculations or flops, is roughly 6 times the number of parameters, which are kind of like the little knobs the AI can tune, multiplied by the number of tokens in your training data, which are basically just pieces of words. It's simple, it's powerful, and it is absolutely fundamental to everything. But that just brings up the obvious question, doesn't it? Why 6? Where on earth does that number come from? It feels kind of random. All right, so 2 of those 6 flops come from what we call the forward pass. This is really simple. It's just the model making a prediction. You feed it some data, and it takes a guess. That single guess costs about 2 flops for every single parameter in the entire model. But then comes the backward pass. And this is where the actual learning happens. The model looks at its guess, compares it to the correct answer, and sees how wrong it was. Then it adjusts all its internal knobs so it can do better next time. And this whole process of learning from its mistakes, it's way, way more computationally expensive. And as you can see, the backward pass is about twice as expensive as the forward pass. So let's do the math. We've got 2 flops for the guess and 4 flops to learn from the mistake. 2 plus 4, and there it is, our magic number, 6. See? Simple. Okay, so now we know the total amount of work we have to do. But how fast can our computers actually do that work? That's where this thing called MFU, or model flops utilization, comes in. It's basically a measure of your real-world efficiency. If a GPU is like a Ferrari, MFU tells you what percentage of its top speed you're actually hitting on the road. Anything over 50% is considered really, really good. And this number is the final piece of the puzzle to turn a giant flops count into actual days of training.